Most builders assume that a massive price drop in frontier-level LLMs means the overall architectural strategy remains the same, merely cheaper. The reality is that when a core computational component drops in price by an order of magnitude, the structural logic of the entire stack fractures. This left chart shows a standard production workload, 100,000 agent runs a month, modeled on 2024 GPT-4o pricing. The bill is roughly $9,176. The actual inference, the thinking of the model, consumes 89.9% of that cost. On the right is the exact same workload mapped to 2026 DeepSeek V4-Flash pricing. The total drops to $1,136, and orchestration now consumes 61.1% of the invoice. The model has not become free. Instead, the inference cost shrinks by a factor of 40, while the fixed costs of routing, state management, and orchestration remain static. This inverts the cost composition of the workload. So when the model itself gets remarkably cheap, what actually becomes the financial bottleneck? Everything other than the LLM is now the bottleneck. Because inference has dropped to 18% of the bill, the 2024 goal of minimizing LLM calls is no longer the primary path to engineering efficiency. I'm Bearded AI Guy. We break down the mechanical realities of AI architecture for builders who care about which specific line items dictate system design in production. By the end of this breakdown, you will have a new 4-part 2026 heuristic that replaces the minimize LLM calls rule, plus 3 actionable design reversals. We start with verified baseline pricing. DeepSeek V4-Flash operates at 14 cents per million input tokens. If you utilize their April cash discount, that drops to 0.28 cents per million. Compare that directly to GPT 5.4, Claude Opus 4.7, and Gemini 3.1 Pro Preview. DeepSeek operates at an 18 to 89 times cheaper multiple across the frontier landscape, but the raw price per million is incomplete. Anthropic's own documentation notes that the Claude Opus 4.7 Tokenizer can consume up to 35% more tokens to process the exact same string of text. When you combine hidden tokenizer penalties with aggressive cash pricing economics, the raw API headline numbers deviate significantly from your realized total cost. You can no longer base architectural decisions on a list price headline. Tokenizer behavior and cache mechanics dictate the true feasibility of a system. Imagine your production workload as a physical building. In 2024, the model footprint was the entire skyscraper, and your tooling fit in a small attic. Today, the skyscraper has shrunk to the size of a single room, but the attic remained the same size. Now, the attic is the primary structure. We can map this mathematically using a strict synthetic workload, 100,000 agent runs, averaging 12,000 input and 1,500 output tokens per run. The stack includes a Langsmith deployment, a 20% evaluation rate through Braintrust, 1 pinecone vector environment, and a temporal plan for state management. Looking at this vertical cost breakdown under 2024 GPT-4o pricing, inference dominates. Out of a roughly $9,100 total, over $8,200 goes straight to the model. The orchestration tooling is virtually invisible by comparison. Now we apply DeepSeek V4-Flash pricing to the exact same workload. The inference cost drops to just $210, but the orchestration load, the temporal plan, Langsmith, the vector storage, remains fixed at $694. Because the reasoning engine became so inexpensive, the auxiliary service line items are unmasked. They are now the heaviest items on the invoice. Every time your agent triggers a tool, a web search, a database query, a code execution, it generates an expense line. For years, those fractions of a cent hid comfortably within the rounding error of the massive LLM bill. Now, they often outprice the reasoning that triggers them. This visual equation compares public API costs. A single standard OpenAI web search API call costs 1 cent. A robust 10,000 input, 1,000 output DeepSeek reasoning call costs 0.00168 cents. One single web search costs exactly the same as 6 heavy DeepSeek reasoning calls. This dynamic is actively coded into billing systems. Google Gemini's deep research agent structure explicitly bills the intermediate reasoning tokens generated during agentic loops at standard rates, and then apply separate usage fees for the actual tools. There is also a systems-level latency tax. The 2026 tax break paper documented that mixture of experts models dispatch 8 to 11 times more kernels per output token than older dense models. This increases the compute overhead on your orchestrator. The math is clear. If your agent executes grounded browsing or complex workflow steps, your tool spend will rapidly overtake your intelligence spend. Because the economic constraints have flipped, engineering patterns that were previously dismissed as computationally wasteful are now mathematically ordinal. The first reversal is the best of n with a judge pattern. Explicitly generating 8 distinct DeepSeek responses and then paying a judge model to evaluate them totals 0.0151. That multi-step redundant process is still cheaper than executing a single zero-shot prompt through Claude Opus 4.7. Reversal 2 is the router-first cascade. Frameworks like Frugal GPT and Scope deliver 94 to 98% cost reductions by routing queries to smaller models first. In the past, the extra inference cost of the router itself discouraged teams from building one. At 14 cents a million tokens, that trade-off has vanished. Reversal 3 is multi-agent specialization. Research on Bayesian orchestration shows that spending a high volume of extra tokens up front to build redundant, specialized screening agents reduces expensive downstream screening errors by 34%. Compare those to obsolete habits, like stuffing everything into a single, giant context window to save an API round trip. Methods like Agent Diet prove you can achieve a nearly 60% reduction in input tokens with zero performance loss just by abandoning the monolithic context window. This shifts the engineering priority. Builders can now spend tokens freely on redundancy to suppress the orchestration and error recovery costs that represent the true bulk of the invoice. The naive reaction to this data is to route 100% of your traffic to the 14-cent model. But the strict shape of the task dictates when a $5 model is an absolute requirement. The primary boundary is task horizon. In testing with Rakuten, Claude Opus 4 demonstrated the capability to code uninterrupted for nearly 7 hours. The second boundary is failure cost. Nicholas Carlini documented an experiment where 16 Claude Opus agents successfully built a C compiler from scratch, capable of compiling the Linux kernel. The inference bill was nearly $20,000. A cheaper model cannot sustain the logic required to complete that workload, regardless of how many retries you run. There is also industry pushback against treating DeepSeek as an absolute discontinuity. Leading figures argue that it represents an expected point on the natural cost reduction curve, rather than a disruption of frontier scaling. Other industry leaders maintain that the enthusiasm for the model's unassisted frontier capabilities is overstated. So we replace minimize LLM calls with a precise 4-line 2026 heuristic. 1. Minimize expensive context movement. 2. Minimize needless tool invocations. 3. Minimize workflow chatter. And 4. Pay for the frontier model only when the task strictly requires it. Cheap models are highly efficient tools designed to surround, pre-filter, and clean up for frontier models. They are not designed to replace them on high-stakes, long-horizon tasks. Applying a 2024 optimization heuristic to 2026 infrastructure is financially inefficient. The rules of efficiency have flipped. As we've seen, the cost center of AI engineering has moved up the stack to orchestration, evaluation, and state management. These are now your primary architectural constraints. Cheaper unit prices provide zero protection if your architecture multiplies calls without strict limits. Investor Tamoth Palihapitiya watched an internal AI bill explode to $10 million annually because of unchecked multi-agent Ralph loops. Your objective is no longer finding the lowest API list price. Your objective is to pick the cheapest model capable of keeping both token volume and downstream system retries strictly under control. If this architectural breakdown was useful, subscribe to the channel and drop a comment below identifying the specific line item on your current AI bill that surprised you the most. The structural math driving today's analysis comes directly from the book AI Agents in Action. Tomorrow, we explore what happens when intermediate reasoning becomes so inexpensive you can spend it freely in an episode titled Reasoning Effort Equals None. The model is cheap. Everything else is now glaringly visible on your invoice, and the architecture you built in 2024 is currently optimizing the wrong line.